Great. Welcome all. Thanks for joining. Thanks for joining this awesome session about benchmarking frame remoting protocol, FRP. My name is Ruben. I'm VP Product at Dizzion. I'm joined by Bernhard Tritsch. Thanks for joining, Benny. Welcome.
Hi, Ruben. Nice to see you. And thank you for inviting me to do this presentation together with you. And in a couple of minutes, I'm going to walk you through all the benchmarking test results.
Sweet.
So, taking it from here, that was something that Ruben came up with, like a cooler title, from lag to lightning, independent benchmarking of Dizzion frame remoting protocol versus Microsoft RDP versus Citrix HDX. And it's not about being, unfriendly about anybody in this list. It's more about taking a look where Dizzion stands these days and just use the other protocols as a reference because they are industry standards and Dizzion more or less is the challenger. And naturally, they want to know where they stand. And this is the idea of this project. And I'm so happy that Dizzion invited me, and Ruben in particular, he invited me to do this benchmarking project for Dizzion. And hey, let's dig right into it.
Great. Yeah. Good stuff happening, I know for sure.
So let's get started with the test lab. This is exactly the setup that I'm sitting in front of right now. And if you look at it on the left side, I have, everything that is related to the client device for the endpoint device. And you see the screen. It's a 4K screen, but I can also use it in full HD, keyboard and mouse. And in the center, you see the two reference client devices that I'm using. For this project, I only used the NOC under Windows 11 and not on the left side, you see the Mac Mini 4. This one was not used for the tests here. It was only the tests on the NOC. And you also see that there are very important devices for this test. It's WAN emulators. We're going to talk about these WAN emulators in a couple of minutes. They sit under the screen for the client devices. And there's a good reason for that, because the client devices, or each of the client devices, they are connected through the WAN emulators to the router that connects me here from my lab to the internet. In the center and on the right, this is what I refer to as my lab controller. I use it to do all the screen recording. So the screen recording software is there. And it is the screens are connected to the machine that sits under the desk. And this machine has the frame grabber. This allows me to feed the output of the client machine, the screen output of the client machine, into the frame grabber and then into the video recording software, which allows me to record all the, things that are happening on the screen of the end user device. And again, it's a keyboard and a mouse connected to that. And finally, I have my mobile kit. So when I'm traveling, I have the same thing, a beefy laptop, frame grabbers, a WAN emulator, a mouse. So this is what I'm using when I'm traveling. But for the project here, I only use the equipment that I have in my lab, not the mobile devices.
So what is beautiful about this is that you really record the actual end user experience. So you with what you see on the screen with your own eyes, that's being recorded with the frame grabber itself. And we'll find out later what it means.
And that actually is a unique selling point of the EUC Score testing methodology.
Yep.
Screen recording and using the screen recordings to do the analysis of what happens under different network conditions, under different, if we had different endpoints, what the behavior is when you're using different endpoints. So this is the idea. Great. And now if we look at, the diagram of the test setup, we have the primary device. So this is the endpoint device I was referring to, and it is connected to the system under test. For our benchmarking test, we had two different systems under test, and we used one of them for two different test scenarios for testing the frame remoting protocol and for testing the Microsoft RDP protocol, and a second one that we used for testing Citrix HDX. For that test, and you will see that later, I used a Windows 365 instance with Citrix built on top of that. Now, as soon as I have access to the system under test, what I do is I install the EUC Score toolset, the simulated workloads called SimLoad. It's synthetic workloads. Then there's an avatar, which, well, it is a component that mimics the user. It takes over the role of the user, because you want to be able to interact with the simulated workload. So sometimes you want to do something with them. And the avatar also comes with a component called telemetry collector, which allows us to collect all the performance counters. And there is SimLoad Runner, which is a component that you can use. It's a graphical UI that you can use to start the simulated workloads. But in our case, we always started them from the avatar, because the avatar also comes with a PowerShell interface. So this allows you to control everything from PowerShell, which makes it a little bit more easier when you run such massive test sequences as I did for this project. Now we add a WAN emulator. You've heard about that when I introduced my lab. And we have that lab controller with the video recorder, with OBS Studio to record the screen videos. And I also use it to control the WAN emulator. So I can change the settings, and I can see the WAN emulator monitor, which gives me a good idea of what kind of data flows between the endpoint device and the system under test, and the other way around. Good. Now, like I said, systems under test, it's basically only two different variants, because if you look at it, the Dizzion Cloud PC and Microsoft Remote Desktop, it's exactly the same machine. So the only difference is that for the Dizzion Cloud PC, I connected through Google Chrome via the FRP protocol. And as soon as I was able to use the RDP protocol, I connected through the Microsoft MSTSC component that sits on every instance of Windows, and used the RDP protocol. And like I said, the second VM type that I was using in this test was Citrix Cloud PC on Windows 365. It is located in exactly the same data center. It is the same VM size, but it is a Windows 365 machine with Citrix for Windows 365 installed. And I can tell you something, it was much easier to get access to the Dizzion infrastructure than it was to get access to the Windows 365 plus Citrix infrastructure. This is a story that we could be talking about over a beer, because, like I said, it took substantially longer to get everything up and running on the Citrix and Windows 365 side compared to the Dizzion side. Because Dizzion, it comes with a nice console, and Ruben, he pre-provisioned the VMs. So here, in this case, it's the D8S V5 that he provisioned with 8 vCPUs and 32 gig of RAM. As you can see here in the center, if we zoom in here, this is what you can see easily. And this is what it looks like before you spin up the machine. So as soon as I press the the power off button to power it on, it switches to that kind of user interface experience. So the experience was that the access to the Dizzion console and the Cloud PC from Chrome browser was very simple, and it only took minutes. It was simple and fast setup. The cloning of the VMs and the creation of new accounts was not painful, not at all. And what I really liked is the easy session configuration, like clipboard integration, camera, microphone, USB redirection, 4K display. We did some testing with high quality video, like YUV444, and it is very simple to switch back and forth when it comes to these settings. This is also a screenshot of exactly that part of the console where you can modify all these settings. Ruben, is that something that is easy, simple for your customers to learn?
Yeah, super. It's almost like iOS. You don't have a handbook to learn iOS, right? So like you have search buttons. It's like self-explanatory. So it's straightforward. That's what I see. But still very powerful, because right now you see these session settings on sort of account level, on sort of pool level.
Yes.
But you can also define them specifically on Launchpad, sort of a web interface, or on Sandbox. So there's a lot of flexibility on that as well. So,
okay.
Yeah, very easy.
Well, for me, it was very simple to modify these settings just using this console, and from there, I was able to take it to
Running session.
to the interactive desktop. And here's a screenshot. What it looked like before I started running any of the tests. What you can see here, that EUC Score is already installed. So all the synthetic workloads, the sim loads, are already on the system. And I also installed Remote Desktop Analyzer, which gives me information about, the FRP protocol. You see Task Manager. You see the session stats that come from the frame session. And you see Telemetry Collector GUI. That is a GUI that allows me to check if I'm collecting the right telemetry data, the right performance counters. Because the worst thing that can happen to you when you run that kind of tests, you run dozens or hundreds of these test runs, and then you find out that you did not configure the collection of performance counters correctly, and you missed a couple of performance counters. Bad news, because you're going to lose hours or days or even weeks of testing. And this is why I always make sure that all the performance counters that I want to collect, that they show up nicely. Now,
I run that as well. Like you learn the hard way once, right?
You learn it the hard way, absolutely. So let's go to the real world, because I'm actually connected to this very instance of the frame desktop that I was using for the testing. Now let's switch that to full screen. And now I have to change to the other keyboard and the other mouse in order to be able to interact with the system. So now I can play around with it, and you see everything in OBS Studio, because that is the full screen mode of OBS Studio. And when I run one of these sim loads, then you will be able to see that here in the screen. And you also see, let's take a look at the stats here. Like, what do we have? So, like you've seen it in the PowerPoint slide, this is what I check every time before I run a test. So let's get rid of that and close that, and also go back here, because what I want to show you next is the WAN emulator before we go to the WAN emulator explanation. But here is a little sneak preview. So you see the WAN emulator says 100 megabit bandwidth in both directions, no added latency, no added packet loss, And if I open the monitor window here, then you see what's happening here. Now let's go back to OBS Studio, run this workload, and now you see that this workload does run in the remote session, and we can take a look at the monitor, and you see that all the activities on the network are visible in a very simple way. And if I stop it, I just press escape on the system under test, and you see immediately the network traffic stops. And this is what I'm doing again and again and again, and recording everything. And well, this is, well, benchmarking best practice. Okay, so the simulated workloads, you have seen one now, but I have, I would say, 3 categories of simulated workloads. On the left side, very simple, continuous workloads, which help me to identify problems with packet loss, for example. So if the system is stuttering, and you remember lightning fast or stuttering, so this is one of the things that helps me to identify challenges by just having workloads that do something, well, it should be in a very smooth way, but when I see it stuttering, like the animations or the scrolling or moving an application window across the screen, then I see the effects of packet loss, for example. Then in the center, we have videos and HTML5. So videos is something that people are watching very often in a remote session, or that are embedded in websites, in anything. And it gives me a good impression of how remoting protocols respond to, well, the demand of a lot of bandwidth, for example. The same is true for HTML5 applications. This is why I have the Fishbowl HTML5 application that helps me to identify challenges when it comes to, well, medium animations. And on the right side, it's more like the heavy load that is being generated. And typically, a CPU-only VM may be overwhelmed. So that means that you will not be able to see like 30 or 60 frames per second. Sometimes it goes down to 3 or 4 or 5 frames per second, but it's not because of the remoting protocol. It is because of the limited capacity of the VM. So we want to see both. We want to see what happens if the VM is overwhelmed, but we also want to see, like on the left side, we generate, or in the center, we generate a lot of network traffic. The VM is not overwhelmed, and there it is the remoting protocol that matters if the good quality can be delivered or not.
And especially when you use like OpenGL, WebGL, like heavy DirectX, if there's no GPU or a slice of a GPU, like a vGPU available, then the CPU will try to do its best. But even with these machines, these are all these machines that have 8 vCPUs. Yeah. So not sort of minimalistic VMs. They're like 8 CPUs is a decent amount of horsepower, but not when you're hammering the CPU with OpenGL,
with
DirectX.
Yeah, with those on the right side, it's most likely you're going to max out the CPU capacity. And even though you max out the CPU capacity, you will not be able to see 30 or 60 frames per second.
Correct.
And this is the important message. So do not always blame the remoting protocol, because sometimes it can be the VM size. And you don't see any OpenGL applications in the mix, because OpenGL simply doesn't run without a virtual or physical GPU, and that's a reason.
Maybe a different test for another day. But
absolutely, GPU accelerated VM types, 100%. Okay, now how do I visualize the data that I'm collecting? Because you've seen I'm collecting videos, I'm collecting telemetry data, and every workload writes a log file, an activity file, that gives me an indication of what the synthetic user does or what the system does. Now, I feed that all into an HTML5 application, and this HTML5 application called Sync Player allows me to do all the analysis and then forward it to my customers, in this case to Dizzion, and also share that kind of results with people, with the public, with the world, on the internet, because it's an HTML5 application. It can just run in any browser. And this is the good news. So all of the things that I will be presenting here, you can watch them yourself, not only here in this presentation, in this video recording of our session, because this may not give you the right quality of the different video streams. No, you will be able to get access to all these clips. I call them Sync Player clips, just through the internet, and you can run them on your own machine, on your own browser. The only requirement is that you have a good internet connection, because the videos tend to be large. Now, I mentioned the WAN emulator, and you've seen it. The WAN emulator can be used to modify bandwidth, latency, and packet loss. I can introduce a different, spec to the network. And here you see the connection without, feeding it, going through the WAN emulator. So my primary device is connected to the router, which is connected to the internet, which is connected to the system under test. Now, as soon as I go into one of the network sockets of my WAN emulator, LAN A, from the primary device, and then with LAN B, go to the router and have this management port for the WAN emulator, I can select what kind of settings I wanna choose, and network setting. And this allows me to modify things on the fly if I want to. You've seen the user interface. This is what it looks like. Let's briefly go back and do some fun thing. Let's do exactly the same thing like we did before, but while I'm running it, let's add 150 milliseconds latency on one side and 150 milliseconds latency on the other side. As soon as I press apply changes, that will happen. Now I go back to my test environment. I run it. We see the monitor. Fine. And now we apply these changes. So now you see up here, now we have a delay in one direction and a delay in the other direction of 150 milliseconds. And if everything works as expected, and we go full screen here, we can see some of these changes actually.
Yeah, also reflecting in the frame remoting protocol performance.
In the frame remoting protocol, yeah, we should be able to see.
Yeah.
You see it up here. There was 150 milliseconds.
Yep.
Stats.
Yep. 153, 54.
So yeah, this is exactly what it does. This is how I set up these tests. Typically, I do not change a setting during a test. What I do is I run the test under one setting, and then after all test runs are recorded, then I log out, I change the network configuration, and I log in again, because I don't want to change the settings during a test sequence. Good, but that gives you a good impression how all this testing works. Now, as soon as we have all that set up, now what are the network profiles? Well, we have baseline, unconstrained. I used 100 megabit, even though I have more bandwidth here available. I used 100 megabit as baseline because I wanted to be fair. Because sometimes one day I have 180 megabit connection. The next day I have 220 megabit connection. So these conditions change for my internet router, for my internet connection. To make it fair, I limit it to 100 megabit, which I call the baseline. Then I use high packet loss, 2%, high round trip time, which is 2 times 40 milliseconds latency added, then low bandwidth, which is 8 megabit, then very high packet loss, very high round trip time, and very low bandwidth. And you've seen the very high round trip time, which I configured just 2 minutes ago with a 2 times 150 milliseconds, which adds up to 300 milliseconds round trip time. I have 10 milliseconds to the Azure data center in Frankfurt, or any cloud data center in Frankfurt. So if it's an IBM data center, if it's Amazon, if it's Google, it doesn't matter because they're all in Frankfurt, and I have 10 milliseconds latency to all these data centers. So I can reproduce that kind of results also using different hyperscalers, which is very handy. All right, so now let's analyze FRP versus RDP versus HDX. So what is the impact of different network conditions? What is the comparison between FRP and Microsoft RDP? What is the comparison between FRP and Citrix HDX? And for that, we're going to go into the results. This is basically the report that I sent over to Ruben. And it includes not only a selection of some of the best results, I would say the highlights. It also includes, if you scroll down here, you see here is a detailed list of all the test sequences and the test runs. Each of those links represents a test sequence, which includes between 25 and 30 test runs. So if I click on this, you see the complete list of test runs and with my findings. So this is the hard stuff. So I watch all these videos, I watch all the telemetry data after we've done or I've done all the testing, and then add my findings.
So we use that internally for like pre-sales, for solution architects to help customers and partners. And also with connected with Benny, select the right sort of sim loads and scenarios and publish that in sort of like EUCScore.com context, so that you can also watch and learn from that as well.
Basically, these are the raw results, including the comparisons. So, for example, if we want to compare the low video resolution, well, lower video, standard video quality versus the high video quality, we can just go there and just run any of those. And here, look at the FRP statistics.
So you're comparing like with yellow is YFV 420.
So on the left side, yellow, it is color-coded. So you see here that this is the standard, while here on the right side in the red color, it's the 444 quality. And here we can see if there is any difference. And there are many of these sort of tests where we can just take a look if we can see the difference, and then have, like Ruben pointed out, have this conversation with the developers, with the engineering team. But for our purpose here, it is the comparison. And what I did is I extracted a kind of a best of. And as you can see here, like, okay, let's compare FRP versus FRP under different network conditions, like baseline 0% packet loss versus 2% packet loss, or 0% versus 5% packet loss. And just let me give you one example here. Roller coaster, we have 100 megabit on the left side in yellow, and we have only 8 megabit on the right side in red. And at a certain stage, you'll be able to see that there are more artifacts in this video playback. So as soon as we go into the fire with the roller coaster. Typically, that is a moment when you see most of the artifacts. Let's just wait for a little bit
Almost.
until it happens. And, well, here you can see a little bit of the difference, maybe not so much when you're looking the Zoom video. This is why I said earlier that I want to give you access to the real results. And here you can see it quite easily. It's stuttering. We only have 2 megabit per second. You can see it down here.
Yeah, playing a full HD video over 2 Mbps connection.
Through 2 megabit per second, and you see massive stuttering on the right side while it's very fluent on the left side. And that is exactly very low bandwidth affects image quality and frame rate. This is kind of the results. But now let's move on and go to, well, FRP versus RDP. And you see, if there is an unconstrained network, well, typically there's no visual difference or very little visual difference. Sometimes you see a smoother scrolling. Like I said earlier, sometimes it is the simple applications that show you a difference, because here you see it is very smooth on the left. It is like a slideshow on the right, which is the RDP protocol. So this is what the RDP protocol does to optimize sort of the bandwidth consumption. And you can see easily that FRP is using more bandwidth because the scrolling is smoother. There's a price you have to pay for the better quality. And
there's bandwidth enough. So yeah, why limit? Why limit if there's bandwidth enough? Well, that's the thought process here.
It is a design decision.
100%.
By product management and by the engineering team, what they want to do. If they focus on higher quality, or if they focus on low network consumption. It's harder to see here, but it's pretty much the same thing, that some of the transitions are smoother on the left side with FRP than they are on the right side with RDP. And again, the price is slightly higher network consumption. And we can also take a look at the CPU consumption, and we can see that FRP requires a little bit more of CPU capacity in order to deliver such a good quality. And now we go to the next, where we introduce, oh, this is a typo. This should not be 2%. So I got to change that.
No, it is all good.
That is 0%. There is actually a typo in here. Wow. Mm-hmm. Good to find it during the presentation.
No worries.
But you see the stuttering here on the left side. It's easy to see. You remember that I said these workloads, the simulated workloads in the left category, in the first category, those are designed to run very smooth without very much bandwidth consumption. But you can see the effects of a constrained network. And if we go to the 5%, it's even more massive. You see, it completely comes to a stop on the left side. I got to fix that in the title.
So RDP, if you go back, Benny, so the red is...
Oh, no, these are the same. Yes, it's... One is...
So RDP is stuttering big time here.
RDP is stuttering. It's correct here, the title.
Yeah.
Oh, my wrong. Because I was still in the scenario where comparing FRP versus FRP. No. Here you see that FRP is able to deal with the packet loss in a much better way than RDP does.
Interesting, huh?
Thank you, Ruben. You brought me back to the
extra pair of eyes.
Yeah, thank you for that. Now let's do the same thing with the photo gallery, which is a Ken Burns effect, something that you see very, very often in very popular websites. And here the packet loss does not impact FRP too much, while, hey, here on the RDP side, on the red side, on the right side, it takes a while until it does something. So the packet loss affects RDP a lot more than it does affect FRP. Roller coaster, again, something that should just roll. And it does. But then at certain stages, it comes to a complete freeze frame on the RDP side. So you see, it cannot compensate so easily for the packet loss. It takes like 2, 3, 4 seconds, 5 seconds to recover from the packet loss.
Also good to know that you see like 28, 22, 23
yeah, it's the same.
frames per second, but that's like rendering on the sort of on the server side.
In the frame buffer. It's the rendering in the frame buffer.
Correct.
And then the question is how many frames can be delivered to the endpoint and what happens when you have packet loss. And here you can see very easily what the difference is. And same is true if we add round trip time. But the thing is, adding round trip time, you see no visual difference. The only thing is, in order to maintain the high quality, FRP requires more bandwidth. This is the typical thing that we see. Now, this is why I don't want to show that, because there's not much of a visual difference between the two. It's a little bit more clear when you start reducing the bandwidth. Let's go to the last one with 2 megabit and see what it does when the RDP protocol only has that low bandwidth available. We can zoom into each of these videos, and now even in this video recording, you should be able to see the artifacts that it generates, like block artifacts. So it is the quality is not as good as it is over there when we're looking at FRP. Yes, sure, it's only a very small, a very low bandwidth, but FRP is able to deal much better with it. So these are the results of the comparison between FRP and RDP. And now let's go down and look at FRP versus HDX. Oh yeah, before we go there, let me mention one thing. Across almost all workloads, and regardless of the network conditions, the FRP session requires more CPU capacity than the RDP session. And I said that earlier, the price is that the graphics quality is lower on the RDP side and higher on the FRP side. So this doesn't come out of nothing. You need more capacity on the system resource side. Now, if we go to the Citrix comparison, FRP versus HDX, no visual difference at the beginning, packet loss, and here we have smooth animation on both sides. HDX session shows more artifacts in under 5% packet loss conditions. Something that came as a big surprise for me, because the HDX protocol is well known for being able to deal very well, and you can see those effects here if you look into that you see some of these block artifacts, and they are more as they are on the FRP side. The thing is that obviously under Windows 365, applying all the policies that are necessary to show a good image quality, it did not work. And you see it here in the end. You see the difference. Wow, all these blocks here, and compared to the very smooth a nice image and graphics quality on the FRP side. It's fascinating to see that. And like I said, it looks like the Citrix policies that dig out the strength of the HDX protocol were not applied properly here. Because I didn't have access to the management consoles, neither in Intune nor the Citrix console, because there are so many bells and whistles that you can change in a Citrix environment. And this may be the disadvantage of the HDX protocol when we ran these tests, because FRP auto adapts. Citrix has a ton of policies to optimize it for optimize HDX for different network conditions. Maybe that did not work so well here. I will need to review and test that again. I have conversations with Citrix, and then we can do yet another comparison, because everybody wants to know what works best.
But at least use the solution out of the box.
Absolutely, use the solution out of the box.
And especially for cloud PC, like an enterprise like deployments, there are like Citrix ninjas and super experts who know what to do.
Oh yeah, absolutely.
With cloud PC, it's a different audience as well. So
that is correct. Cloud PC, the audience is not the expert; it's more the generalist. And so things should be working out of the box.
Yeah, really.
And here we're easily able to demonstrate that FRP works out of the box, while we need some tuning on the Citrix side. I'm going to find out why this is happening. And here's an interesting case, because here the CPU consumption is higher on the Citrix side. I don't know why. This is a scenario where we really see higher CPU consumption on the red side, the Citrix side, compared to the FRP side. Other than that, most of the comparisons between FRP and HDX showed that, number one, there's not a big difference between the two. Number two, the CPU usage is almost identical. So look at that. Yep. So yellow is FRP, red is Citrix. It's almost 100%. Yeah, we're talking about like, hey, 83, 87. Yeah, so it is almost identical, except for the network consumption. So here, FRP requires more network than HDX. But the quality, as I pointed out earlier, is better on the FRP side. And we can reproduce that also under, very low network conditions. Again, if you watch closely enough, you'll be able to see that the quality is lower on the red side, on the right side, compared to the left side. So it is some of these results that repeat, and this gives us confidence that we can come to the conclusions that I have both here in this document and also when you go to my article that I just published yesterday, Dizzion Cloud PC Benchmarking with EUC Score. So if you scroll down, you will find lots of the information that I just shared with you, but there are also the links that lead you to the test results. And here are these test results, like the impact of different network conditions on the FRP protocol. And you can see this is, you can see that from the internet. And so all of these results that I had in my slide deck, or that I referred to in the slide deck, they are available here on this website. So as soon as you click here, now it opens through the internet and it shows you exactly what you have seen when I played it back from my file server.
The beauty here is that you just use your own machine, so there's no Zoom and sort of webinar
yes.
recording.
In this case, you use your own machine, your own browser and everything, and that makes it so much more powerful than watching all of that over Zoom or over a video recording.
Hey, Benny, what I really like about the player is that it combines like telemetry data and user experience data. And like the video, the user experience, and the telemetry data. That's something really unique in our industry, because you can zoom into like the telemetry data alone, but that's just half the story. And that's,
for example, when we scroll up here and go to the frame side-by-side comparisons, like let's just pick a random one here, bandwidth 100 megabit versus 2 megabit per second. I click on that one. Okay, it runs. It shows me the standard stuff. And like Ruben said, I can zoom in and watch everything in detail. I can see what the system under tests are, what the difference is between those. That's no problem. But
report also is handy, like the report button.
The report. But I also have a link here with FRP telemetry. That shows the FRP telemetry data that was collected. So you see the FRP performance counters. Yes, there is a report button. Sometimes you also see the findings of the comparison here, but you always see the findings of the individual test runs in here. So it gives you some extra information of what you are seeing here. And this makes it very powerful for analysis. Thank you for pointing that out, Ruben. Good. What are the key findings? Well, without network constraints, well, we don't see a big difference visual difference between FRP RDP 11. I refer to it RDP 11 because it's not the side-by-side RDP protocol as you find it in Windows 365 and Azure Virtual Desktop. It is the classic RDP protocol stack, and as it's installed on Windows 11. So I refer to it as RDP 11 to differentiate this protocol variant with the side-by-side protocol and the HDX protocol. I mean, as I said many times, FRP shows good, brilliant image and animation quality, requires more bandwidth. FRP is very good at compensating for packet loss. We have seen that a couple of times. With increasing latency, FRP also shows good performance, but the price is it requires more bandwidth. Low network bandwidth is not a problem for FRP. That's something that I found. And then coming back to the CPU consumption, many times the CPU consumption is identical when you compare FRP and HDX. When you compare to RDP, RDP requires less CPU, but at lower image and animation quality. And I also pointed that out earlier. These are the key findings here. And like I said, check it out yourself. This is the link to the article that also includes the links to all the EUC Sync Player clips, allowing you to compare these results, the test runs side by side. And with that, hey, thank you for attending our session. Ruben, are there any final remarks that you have?
Yeah, what I like about this test is that people can just watch and learn from what you shared about, like benchmarking itself, the setup, but also the results, FRP, RDP, HDX, and draw their own conclusions for their own context. So it's always good to have this kind of info available publicly. Yeah. And that's why I love this kind of data and this kind of benchmarking.
Ruben, thank you so much for making that a partially commercial project on one side.
Sure.
But on the other side, you said, okay, let's publish the results. Let's just get them out in the wild. And even if if FRP may be losing in one scenario or the other, just let's make sure that people understand what the difference is. And this is something that I really appreciate because number one, it generates some revenue stream for me on one side, but on the other side, we both are able to share that kind of results with the world, and well, also spread the word that FRP is a protocol that is very mature, so it can keep up with the other mainstream protocols that are out there in the market. This is my personal conclusion.
What I also find interesting is that like we do everything in browser, while for the others the browser is the backup plan.
Yes.
Well, maybe like 80% of our time we already live in browser, so why use something else to access virtual apps and desktops? Maybe somewhere in time we'll be able to do like a comparison where you don't use the native native client, but just use the browser, because for many of the other vendors in this space, the browser is like plan B, like backup plan. But nevertheless, like we try to keep it fair for machines, like the machine types itself, the network, of course, but also like using the latest like client on the Citrix Cloud PC and RDP side, and on the frame side, it's just browser, so all good.
I mean, Dizzion and the frame remoting protocol, you have a different history. You come from the browser as your primary output component, while all the other remoting protocols, they always had their remote desktop client software. And then they also, like you said, as a plan B, they offered the same functionality in a browser. Now you started going the other way around and started implementing your own components so that you can run outside the browser sandbox. It is very interesting to see what's happening in our industry, that you can have different solution for the same problem. What I want to add here is a couple of EUC Score links. So if you want to check out the documentation, the test methodology, the gallery of all the different simulated workloads, some of the test results, I mean, you've seen examples of that, a glossary, the lab equipment that I'm using. But when you go to the article, if we go back to the article here, what I also did, I added the slide deck. So if you click on this link, it opens the document, so you have that slide deck available to you. So everything is in this article. So I want to recommend, if you want to find out more details, just go to this article and check it out. And I think that Dizzion will also talk about it and create their own content based on the test results. And like Ruben said, I really look forward to do more testing because whenever you run a test and whenever you have results, that opens new questions that you want to answer.
There are two things, Benny, I just thought about when you talked about the connection to your website. So another call to action is TryNow. So if you go to Dizzion.com, there's an icon called TryNow. The default TryNow setup is CPU-only machines, 4x16, in Amazon, Azure, Google, IBM, and Nutanix. That setup is also equipped with the EUC score Benny is using. So if you want to see Dizzion in action from your own machine, that's the whole TryNow design purpose. Go to Dizzion.com. There's an option TryNow. You can run all kinds of stuff, including like EUC score. If you want to really play around with GPUs, NVIDIA GPUs, there is a special invitation code I can share, which is not publicly available, but I can share. So feel free to reach out, Ruben at Dizzion.com, and I can share a special invitation code to unlock TryNow and go from CPU-only machines to GPU machines. And these GPU images also include EUC score, but also include EUC score with the GPU, like heavy workloads, like the OpenGL and DirectX workloads, and a bunch of Adobe, Autodesk, Enscape, Unreal, like all kinds of GPU-based like workstation apps. So if you want to play around with that and also play around with EUC score, TryNow is a good segue into trying it out.
Yeah, if you go to my homepage, drtritsch.com, and there are the latest articles, including this benchmarking article, but there's also the article about the Dizzion TryNow with pre-installed EUC score tool set. thing. So if you click on that here, there's a step-by-step guide how you get access to the TryNow environment run by Dizzion, including the EUC Score toolset.
Yeah.
Thank you for pointing that out.
Yeah.
I did not have that.
I just remembered, so like, hey, this is handy for folks listening in. So.
Absolutely. Thank you for that.
Good.
Good. With that, I want to say thank you so much.